This video is going to review with you the notes that you need for trigonometry for the Algebra 2 Regents. So we're going to start nice and easy with SOHCAHTOA. Remember that SOHCAHTOA is an acronym to help you remember your trig functions. Sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. When you're drawing a triangle, you always want to make sure that we draw it on a coordinate plane, like an XY axis. And your hypotenuse should always be drawn from the origin, and the triangle should always be drawn back to the X axis. And to help us, we draw a bow tie triangle sometimes, so that would look like this. So you don't always need to draw your entire set. If I was just drawing a triangle in quadrant 3, it would look like this. There's my right angle, and your angle that you're talking about is always at the origin. So remember, if I'm in quadrant 1, this is positive x, positive y. Quadrant 2, negative x, positive y. Quadrant 3, both negative. Quadrant 4, positive x, negative y. If you need to label your quadrants, you can do that as well. Quadrant 1, 2, 3, and 4. So our reciprocal functions, each of our 3 basic trig functions, sine, cosine, and tangent, all have a reciprocal function. So first we have cosecant. The abbreviation is CSC, and that's equal to 1 over sine theta. Or you can just flip, instead of opposite over hypotenuse, it's hypotenuse over opposite. The next is secant. The abbreviation there is SEC. That's equal to 1 over cosine, or hypotenuse over adjacent. And then lastly, we have cotangent. The abbreviation is COT, and that's 1 over tangent, which is equal to adjacent over opposite. Now remember that tangent and cotangent make sense, they sound alike, but the other two can be confusing, so it should always have a pair. Cosecant starts with a C, so its reciprocal starts with an S. Secant starts with an S, so its reciprocal starts with a C. Unit circle. The equation of the unit circle is x squared plus y squared equals 1, which means it has a center of 0, 0, and it has a radius of 1. So that means this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And you can label all of your quadrantal angles on here. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We'll talk about angles in a minute. If I am on the unit circle, the point x comma y is the same thing as cosine theta, sine theta. So x is equal to cosine on the unit circle, and y is equal to sine on the unit circle, which means that tangent is equal to y over x, which is sine over cosine. So let's talk about some angles. Angles drawn in standard position always start on the positive x-axis. Positive angles rotate in a counterclockwise direction, and negative angles rotate in a clockwise direction. So here is my axes. Here's my initial side. If it's going in this direction, it would be something like a positive 60 degrees. If it was going in this direction, it would be something like negative 135 degrees. Your quadrantal angles I briefly talked about with the unit circle. They divide the angles on your axes, 0, 90, 180, 270, and 360. A reference angle is a positive acute angle formed by the terminal side of the angle and the x-axis. We always go to the x-axis for anything. So we are always going to calculate using 180 or 360. Coterminal angles are angles that are in the same position. They have the same terminal side. And in order to find them, we add or subtract 360 degrees because that's a full circle. So for example, here's my angle of 30 degrees, let's say. And if I rotate 360 and another 30, that's 390 degrees. So 30 plus 360 gives me 390. Your Pythagorean identity for trig is sine squared theta plus cosine squared theta equals 1. Radians are another way to measure angles. So instead of degrees, we can measure in radians. These formulas are on the reference sheet, so you do not need to memorize them. But it's 1 radian is equal to 180 over pi degrees, or it's 1 degree is equal to pi over 180 radians. And you always want to start with the formula that you know. So for example, if they're saying you have 135 degrees, convert to radians, you always want to start with the degree formula because I have degrees. So this would be the formula that I copied down from the reference sheet, multiply both sides with 135, and simplify from there. Remember, if pi is to be put in the calculator, they will give you rounding directions. Pi only goes in the calculator when they give you rounding directions. So that's all of our basic information about trig. Now let's talk about some graphs. Sine and cosine are the two main functions that we have. So here is your parent function for the sine function. Remember that these do technically go on in either direction. It's a 5-point pattern that we follow. So this is midline, max, midline, min, midline. If it was a reflection, so if it was a negative sine graph, it would still start at the midline, but it would go down first. It would look like that. Cosine, your 5-point pattern, looks like this. So it's maximum, midline, minimum, midline, maximum. And a negative cosine would start at the minimum. It would look like that. And then we have our tangent function, which does not come up so often, but just to be able to recognize it. Your tangent function looks like this with asymptotes in the middle. The asymptotes occur at a pattern every 90 degrees. So 90 degrees, 270 degrees, and so on. Negative 90, negative 270, and so on. So when we are asked to graph sine and cosine, these are our two basic equations that we have here. A is your amplitude, B is your frequency, C is your horizontal or phase shift, and D is your midline, which represents your vertical shift. There's lots of vocabulary that goes along with graphing. So your midline is your horizontal reference line. It is not actually part of the graph. It's located in the middle. For word problems or interpretations, we're looking for the word average or middle. Amplitude, it's half the distance between the maximum and the minimum. So your formula is 1/2 maximum minus minimum. The important thing to know, especially when you are looking at an equation, is that your amplitude is always positive. Amplitude is a distance, so that negative talks about the reflection. It doesn't talk about the actual amplitude being negative. Maximum and minimum is your highest point or your lowest point on the graph. In order to find them, you take your midline and you add the amplitude, or to find your minimum, you take the midline and subtract the amplitude. All of these on a graph deal with the y-axis. So then we have frequency. Frequency is the number of times, how frequent something occurs or how frequent my pattern is. And we talk about it between 0 and 2 pi. So you should be thinking about how many for word problems. Your formula for frequency, if you need to find it, is 2 pi over the period. Period is the time it takes, so you should be thinking how long. And remember, it's for one full cycle. If you need to find the period, it's 2 pi over the frequency. And then lastly, we have quarter points. Those are used to label your x-axes. They're found by taking the period and dividing by 4. There are 4 quarters in a football game, 4 quarters in a dollar. So we're dividing by 4. And then you count by ones in the numerator. So for example, if my period is pi over 4, my labels on my x-axis are 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. That would give me one complete cycle. If I needed to extend my graph based on a given domain, I could continue counting. 5 pi over 4, 6 pi over 4, and so on. And all 3 of these vocabulary words are related to the x-axis. So that is all of your information for graphing trigonometry as well.